Welcome to this session of Understanding Human Anatomy. I'm going to continue talking about the upper extremity, and I want to move into talking about the muscles of the upper extremity. But before I do so, I'd like to spend some time talking about the way muscles act and how they act. Now, one rule you must understand. Or rule. Muscles can only act. They can only do work. When they are attempting to get shorter. A very important rule to remember. When muscles act, the two attachments of the muscle, the two ends of the muscle, get closer together. So if you understand where the muscles attach, and usually this doesn't have to be to the exact millimeter, but the approximate point of attachment, you'll know what the muscle is going to do. You can figure it out. So this is an important rule to keep in mind. Now, two of the most basic actions of muscles that we talk about are flexion and extension. Flexion. Flexion is defined as when the angle between two bones is decreased. So in our diagram here, and I've just used two rectangles to indicate two bones, and the dot is the pivot point forming the joint. If we bring bone number 2 closer to bone number 1 in this direction, that is flexion. So this angle between the two bones is made smaller. So we are flexing this joint. Now, the opposite of flexion is extension. And extension is defined as when the angle between two bones is increased. The angle between two bones is increased. So if we are looking at, again, at our example here, if we make bone 2 move further away from bone 1, if we increase this angle, so if bone 2 moves in this direction, so that when this angle between the two bones is increased, then that is extension. Now, if a muscle is on this side of the joint, the muscle is on this side of the joint, it will have to flex. If the muscle crosses on the opposite side of the joint, it will have to extend the joint. So let's look at what can happen. If we take a muscle and have it run between bone number 1 and bone number 2, like so. Given its location, this muscle would have to be a flexor. And let's just call this muscle A. Muscle A is a flexor. And if we add another muscle, muscle B, like so, and we'll color it in. Muscle B will also be a flexor. So both of these muscles are flexors. Because they're on that side of the joint. It's the only thing they can do. They can only do work when this end and this other end, the end attached to bone 1 and the end attached to bone 2, come closer together. But there's something else that we can say just looking at this diagram, and it comes from basic physics. Because of their relative attachments, muscle A is attached to bone number 2 much closer to the pivot point, to the fulcrum, than is muscle B. Muscle B is attached much further out. Therefore, muscle B is going to have a greater mechanical advantage than muscle A on moving bone number 2. It will be able to move more weight. So muscle B has a better mechanical advantage than muscle A. Now, if we look at the other side, if we have a muscle back here that attaches to bone 1 and runs on the opposite side of the joint to bone 2. And again, we'll color it in. And we'll call this muscle muscle C. Muscle C is an extensor. Because it lies on the opposite side of the joint. It crosses the joint on the opposite side. Now, we can say a couple of more things. We can say that muscle A and muscle B act synergistically. Or they are synergist. They both do the same action. They both flex the joint between bone 1 and bone 2. So they help one another. On the other hand, muscle C acts opposite both muscles A and B. That is to say, muscle C is an antagonist to both muscles A and B. And we're going to find that whenever we're looking at joints in the body, that there will be muscles acting opposite one another. We will have what are known as antagonistic pairs. Now, don't take it too literally. Pair does not mean just two muscles. In this case, the antagonistic pairs are C for one action and A and B for the other action. So there's three muscles total. But the pair refers to opposite actions. Occasionally, the primary antagonist might be gravity. But even when gravity is a primary antagonist of a muscle, there will be other muscles there that also act antagonistically. One more common action, and again there'll be pairs, is abduction and adduction. Abduction and adduction. Abduction is defined as moving in the lateral plane or lateral direction away from the midline. So, if we were looking at this crude drawing, and we used muscles to move the arm at the shoulder out to this position. So we move from here to there, straight out to the side. This is abduction. Adduction is defined as moving in the lateral plane so that the limb is brought closer to the midline. So again, going with our drawing, if we started out in this position, and we brought the arm back down to anatomical position in this direction, this would be adduction. So ab and adduction. These are the most common actions of muscles. There will be some others, and we'll talk about them when that happens. But these are the key ones that we need to understand. So, in the next video, we'll start looking at individual compartments in the upper extremity and what the muscles in those areas do. Thank you for your attention.